Data silos slow down AI and analytics. What if you could unify enterprise data effortlessly, without complex ETL? Meet Acumen Vega, the fastest way to accelerate BigQuery and Looker adoption. With write once, read anywhere, Vega makes structured and unstructured data instantly accessible, powering a data lakehouse architecture to deliver self-service AI-driven insights at petabyte scale. Vega can seamlessly read from SQL Server, Postgres, MySQL, Snowflake, Oracle, and even files such as CSV Parquet. It can even write data into each of these data systems. To accelerate ML model training, it can generate high-quality synthetic data for secure, compliant AI models. Now, let's jump into the demo. The use cases we have chosen: model an organization that has multiple data sources of information across files such as CSV and Parquet, in addition to databases such as SQL Server, Snowflake, and Postgres. The architecture showcases the Acumen Vega platform, which is completely built with the Python programming framework. The solution can be fully deployed on a standalone low-cost Windows VM as a Kubernetes deployment and integrated into your CI/CD for continuous processing. Let's show you how Parquet data files convert to Iceberg. We will be selecting the source data file. Click on Option Data Files to Iceberg. Now we provide the necessary credentials, source path and destination to begin the process. View conversion screen. The conversion is complete. Let's open the Iceberg files that got created in the GCP bucket. Let's view the Iceberg warehouse, database, and table. Inside this table, there are data and metadata folders and the related Iceberg files such as snapshot, manifest file, manifest list, version files. Now, let us run a database conversion. PostgreSQL to Iceberg. Let's start by selecting an on-prem PostgreSQL as the source. Now, let's click on PostgreSQL to Iceberg. Let's provide the credentials, source path, and destination, and run the conversion. View conversion screen. Now, let's open the Iceberg files created in the GCP bucket. Now, let's view the Iceberg warehouse, database, and table. We can see that the data and metadata folders and related Iceberg files, such as snapshot, manifest file, manifest list, and version, are created. Now, let us run a SQL Server to Iceberg conversion. Let's start by selecting on-prem SQL Server as the source database. Click on SQL Server to Iceberg. As earlier, let's provide the credentials, source path, and destination. View conversion screen. As earlier, the appropriate Iceberg data files such as snapshot, manifest file, manifest list, version are created. Now, let's go the other way, from Iceberg to PostgreSQL database. Here, we will source Iceberg data from a GCP bucket and populate a PostgreSQL database with the data coming from Iceberg. We are checking whether there is an existing table present in the PostgreSQL DB. If it is not available, it will be created as part of the process. Now, let's click on Iceberg to PostgreSQL. Let's provide the necessary credentials. View conversion screen. Now, let's verify the destination database, PostgreSQL DB, using dbweaver. Now, let's perform an Iceberg to SQL Server conversion and put data into a SQL Server database. Let's start by opening the Iceberg files from the GCP bucket. Now, let's click on the Iceberg to SQL Server menu. Let's provide the credentials. View conversion screen. Now let's verify the destination database, SQL Server, for the converted data. Here are the highlights of the data performance. Here is the system configuration we use to run the conversion. And here is the cloud storage network cost. Let's start your Iceberg conversion journey.